Welcome to this structural workflow demonstration using Trimble Connect. Here we have Tekla Structures modelers working with structural steel, cast-in-place concrete, and precast concrete, and they're all in their individual companies and doing their individual portions of the building. And what we're going to do is we're going to show how they can actually reference each of their models for coordination and doing connections between their trades, and then combining everything together into one coordination model. Now, this is different than multi-user and different than the Tekla Structures model sharing. The difference here is that we're publishing reference models to Trimble Connect on the cloud, and then we're basically going to reference each one of these different trades into each other's models. This means that the geometry that's referenced in, say for instance from the precast model to the structural steel model, cannot be modified by the structural steel contractor. It can be inquired, it can be clashed against, it can even be modeled around, but it can't be modified or changed in any way. And the other advantage of using the reference models and publishing the models to the cloud is that we can control which attributes and which properties and even which objects we want to share and synchronize out. This fosters a protected workflow between the different contractors. It would be very similar to them exchanging 2D drawings, but instead they're exchanging protected reference models, which reduces duplicate modeling and simplifies sharing and collaboration. Okay, so we're going to start here within the structural steel model, and we're going to publish our model to Trimble Connect on the cloud. And here we'll just go ahead and say steel model. We're going to select all of our objects here, and we'll press OK. It's then going to publish that model, and here we can see that the model is now published to the cloud. Alright, now we're in the cast-in-place concrete model, and we can see here that the steel model has been published. If we want to, we can actually get this from the cloud, and we can reference that in here into our model. We can select any of those objects, and we can inquire their properties. So these are the properties that were published from the steel contractor. We can then zoom into the location where the steel interfaces with our concrete, and we can verify that everything is correct and that we don't have any clashes. Now let's go ahead and publish our model out to the cloud. Now here in the precast concrete model, we'll repeat this process. Let's go ahead and download the cast-in-place model, and then we'll also make the steel model visible. So now we have both sets of models as references here with our precast concrete. Again, the key difference here is that with the reference model, I can only set user-defined attributes, which are for my reference. On the precast model, if I double-click on it, I can actually modify the geometry and change the representation of this particular object. Now let's go ahead and publish our model. Now we're in a pure coordination model, and construction managers, project managers, contractors, as well as even field personnel can leverage this model for scheduling, clash checking, as well as layout points for the field. Alright, so let's go ahead and make the models visible. Let's go ahead and zoom into this footing here in the model. Let's create some layout points that can be used by the total station and field link out in the field. These points in geometry can also be published to Trimble Connect in the cloud. Now we're back in the cast-in-place footings model. We're going to select all the footings, and we need to make a change. We'll go ahead and modify that geometry, and we'll update the cloud. I'm now back in the coordination model, and we can see here on the cast-in-place model that a new revision has been uploaded. We can then make that visible from the cloud, and it updates the model. When I zoom into this particular footing, you can see that the layout points on the bottom need to be moved. Now that those have been moved, we can update the cloud with our new layout points. So in summary, each different contractor was able to work in their own individual Tekla structures model, and then they could choose which model objects as well as which properties that they'd like to publish to the cloud. Then each individual contractor can reference that information and then work in a collaborative environment. But the big key thing here is that each of the contractors can be assured that their models and their information are protected, and they can control which information is shared to the other contractors.